The universe is an interminable fractal fundamentally made out of an unending number of endless impacts known as negligible enormous bangs. If you consult the science course book conveyed before 2006, you will see that Pluto was integrated as one of the 9 planets in our planetary group. Anyway, this is no longer the case. Something like 10 years prior, the Worldwide Galactic Association renamed Pluto's status and barred it once more as a planet. Now the IAU is examining this issue since NASA has given clear pictures of Pluto, now seen as a bantam planet. Join us on an excursion to the most distant compasses of our solar system to explore the main pictures of Pluto in our history. If you're excited about staying informed about news from the universe and its peculiarities, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've made some significant advancements since the notable Apollo 11 mission, yet the boundlessness of space presents a large number of unanswered questions. This is where NASA's urgent James Webb Space Telescope project plans to investigate its very own vast expanse. This astonishing task develops NASA's past missions, and there is great interest in translating extraordinary discoveries from old times. We are naturally curious to learn more about the Big Bang and how our local planetary group came to have life on one of its planets. The James Webb Telescope, however, has its sights set on the eventual fate of our planetary group, transforming our understanding. It is critical to decide whether we really need to look back for conclusive answers about our universe and maybe rethink them. The Pluto question has been a subject of conflict in the field of space exploration. Because of the James Webb Telescope and the discoveries it has provided, we now have more information to investigate our local planetary system. It seems that the $11 billion investment in NASA has prompted an update of science course books to include everything we know about Pluto. This time, it is likely to recover planetary status. Here's the reason: our data about Pluto doesn't end with the questionable IAU decision in 2006. In reality, it is the new and improved capabilities of the James Webb that have provided the pictorial evidence required to support our hypothetical understanding of this putative planet. Although past characterizations figured out which objects were viewed as planets and which were not, the IAU had limited solid data on which to base their decision. The principles utilized for this classification might have been addressed after the decision in 2006. 2 unmistakable scientific viewpoints on the issue have emerged. Some believe that the IAU was rushed in proclaiming Pluto a bantam planet, while others quickly accepted the new non-planet status. Most spacefarers have remained unsure regarding this issue. However, because of the charming discoveries of the James Webb, the topic of Pluto's status remains unsettled. The initial sharp pictures of Pluto given by NASA are updating how we interpret cosmic history. The first and basic human experience with Pluto was driven by the New Horizons mission, which has been continuous for quite a long time. In July 2015, the mission accomplished its goal by passing close to Pluto and its many moons. This was when individuals originally got the opportunity to get a close glance at the space object and gathered the most extensive data set to date about its moons and surface. The New Horizons mission opened up excellent opportunities for NASA in its investigation of the Kuiper Belt, a far-off area of space. The essential outcome of the mission was the detailed investigation of Pluto, now viewed as a dwarf planet, and its largest moon, Charon. It also managed to capture clear pictures of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission accumulated data, including the experience with Pluto and Charon, amounting to 6.25 gigabytes. What does this information mean for NASA in regards to the bantam planet? First, the discoveries were so momentous that researchers needed to develop new data models to better understand Pluto's surface and atmospheric conditions. It was found that the bantam planet was undergoing huge changes in its surface and atmosphere. It was clear that Pluto was a long way from being a lethargic body. It was developing at a rate that shocked NASA and challenged past convictions about this putative planet. The New Horizons mission was critical, and its experience with Pluto happened nearly 9 years ago. Since then, the field of space exploration has seen dramatic improvements through technological advancements. With the addition of the James Webb Space Telescope, the possible outcomes are becoming interminable. One could even say that we are getting progressively closer to a total understanding of our local planetary group. However, there is an issue with missions like New Horizons and any endeavors to explore planets further from the Sun. The issue lies in the prioritization of resources, as effective financial planning for millions to study an experimentally significant planet could raise questions about the existence of possible life elsewhere. Why head to the edges of the local planetary group? These are moving inquiries, certainly. Regardless, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new roads for NASA to invest in the investigation of Pluto, but it also sparked our interest in further exploration past known limits. In the case of Pluto, its study is critical to building a broader scientific understanding of other small planets. Despite lying in a cold, dark region of the universe, the initial pictures of its surface were significant enough to reveal that Pluto is a dynamic object in our neighborhood planetary system. As the saying goes, a picture is worth 1,000 words, and these high-resolution pictures from NASA give us valuable information. First, Pluto was found to show a heart shape. Most geological features on this bantam planet are derived from its core, scientifically known as Sputnik planum. Shockingly, Pluto literally leans on its heart. A brief glance at NASA's high-resolution pictures revealed that this heart is a white, nearly frozen left ventricle of Sputnik's heart, appearing like an enormous nitrogen ice sheet covering large numbers of square kilometers. Another striking land feature of Pluto's surface is that the axis of its rotation has undergone significant reorientation, what researchers call a precession cycle. This was unknown to NASA before the mission. The dwarf planet's bowl is in the contrary position than anticipated. This reorientation has critical implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the rotational axis between the moon Charon and Pluto is being impacted by Sputnik planum, the core of the bantam planet. This impact has reoriented Pluto so that its axis is more closely aligned with its rotational axis, something not previously known. We have always known that this far-off planet is complex for obvious reasons. However, what was not known is that Pluto's cold surface also creates a tilt due to the inconsistency in its mass. The core of the bantam planet is a 4 kilometers thick layer of ice, which is possibly contributing to its massive mass. When combined with tides, this process can cause the reorientation of the planet's rotational axis. However, the ice alone isn't sufficient to produce a significant reorientation point or to create meaningful dynamics. As mentioned earlier, scientifically supported investigations can reshape our astronomical history, and this is one such moment. Specialists have also found that Pluto is a world with its own sea beneath its thick ice sheets and frigid surface. Pluto's interior contains a vast ocean, which also influences the reorientation of its rotational axis. This discovery is surprising for multiple reasons, but most critically because it fundamentally changes how we might interpret the planet. The highly plausible presence of a sea beneath Pluto's cold surface means that we will gain information about its origin and how it formed. The revelation of an ocean beneath Pluto's frozen surface has sparked new inquiries and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth and prompts us to reevaluate the characteristics of celestial bodies in the remote reaches of our local planetary group. This ocean, conjectured based on gravitational data and now firmly supported by the New Horizons mission's discoveries, suggests a potential source of liquid water beneath a frozen exterior. Understanding Pluto's geological cycles is significant for grasping its evolution over billions of years. The bantam planet's surface features, including its distinctive heart-shaped region and the surprising reorientation of its rotational axis, provide intriguing insights. Sputnik planum, the heart's left ventricle, acts as a notable land feature. It is believed to be a large bowl that could have formed due to a subsurface sea freezing and causing the surface to collapse, or possibly because of an impact that exposed material, creating a deep depression. The New Horizons mission's experience with Pluto in 2015 revealed a dynamic world far from the cold, inactive body it was once thought to be. The mission captured detailed images of Pluto's diverse landscape, including mountains made of water ice, vast fields of nitrogen ice, and regions with complex patterns resembling cell networks. These features suggest dynamic geological processes potentially driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, thin compared to Earth, plays a crucial role in its surface dynamics. It primarily consists of nitrogen, with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating transient climates that vary with seasonal changes. Understanding these climatic processes helps researchers recreate Pluto's atmospheric history and its ongoing evolution. The New Horizons mission discovered extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, revealed an unexpectedly diverse landscape, including a massive canyon larger than the Grand Canyon and a dark region nicknamed Mordor for its distinctive tint. Other moons such as Hydra and Nix exhibited irregular shapes and cratered surfaces, indicating a history marked by impacts and geological activity. NASA's investigation of Pluto and its moons represents humanity's ongoing mission to explore and understand the vastness of our planetary group. Each new discovery raises further questions about the origins, evolution, and diversity of celestial bodies, challenging existing theories and prompting researchers to develop new models and hypotheses. Beyond its scientific significance, Pluto holds cultural and symbolic value as a distant frontier that humanity has reached and explored. The images and data returned by New Horizons captivated people around the world, igniting imaginations and rekindling interest in space exploration. The mission's success highlighted the importance of perseverance and innovation in pushing the boundaries of human knowledge. Looking forward, NASA's James Webb Space Telescope promises to further transform our understanding of Pluto and other distant objects in the Kuiper Belt. Scheduled to launch in 2022, this state-of-the-art space observatory will peer deeper into reality than ever before, using its advanced instruments to study the atmospheres, compositions, and dynamics of planetary bodies like never before. The James Webb Telescope's capabilities extend beyond visible light, allowing it to detect infrared radiation emitted by objects in deep space. This ability is critical for studying cold, fragile objects like Pluto, whose faint emissions are challenging to capture with traditional telescopes. By analyzing the infrared signatures of Pluto and its moons, scientists hope to gain insights into their surface compositions, geological activities, and even potential signs of organic molecules. One of the primary objectives of the James Webb Telescope is to investigate the origins of planetary systems and the conditions that led to the development of habitable worlds like Earth. By studying objects in the Kuiper Belt, including Pluto and its neighbors, astronomers aim to unravel the mystery of how small, cold bodies interacted and evolved in the early solar system. These discoveries could provide clues about the prevalence of water and organic compounds in other planetary systems throughout the universe. The technological advancements made possible by missions like New Horizons and the James Webb Telescope are clearing the way for future exploration of the outer solar system and beyond. Concepts for future missions include orbiters and landers designed to study Pluto's surface more closely, collect samples, and even search for signs of microbial life in its subsurface sea. The search for life beyond Earth is a central theme in planetary science, driving researchers to explore various environments and assess the potential habitability of celestial bodies. While Pluto's surface conditions are harsh and cold for known forms of life, the discovery of liquid water beneath its icy shell raises intriguing possibilities. Similar subsurface oceans could exist on other icy moons in the outer solar system, such as Europa around Jupiter and Enceladus around Saturn. Studying Pluto's subsurface ocean could provide insights into the conditions necessary for life to arise and thrive in extreme environments. By analyzing the chemical composition of water and minerals in the ocean, scientists can evaluate its potential to support microbial life or preserve evidence of past biological activity. Future missions equipped with advanced technological innovations could penetrate through the ice to sample the ocean and search for signs of life. The exploration of Pluto and its moon system also contributes to our understanding of planetary defense against potential asteroid impactors. Objects in the Kuiper Belt, including Pluto, are remnants of the early solar system and can provide valuable insights into the frequency and nature of impacts that shaped planetary evolution. By examining impact craters and surface features on Pluto and its moons, scientists can reconstruct the history of cosmic collisions and assess the risks posed by near-Earth objects. NASA's planetary defense efforts aim to detect, protect, and track potentially hazardous asteroids and comets that could pose a threat to Earth. By studying the characteristics of the Kuiper Belt and other regions of the solar system, astronomers can enhance their ability to predict and mitigate impact risks.